Hey everyone, welcome back to Scalar. Today in this video, we will talk about working with models in LangChain. But before we get started, make sure you subscribe to the channel so you don't miss the rest of the agentic AI playlist. And if you are serious about building a strong career in AI, check out Scalar's Advanced AI and Machine Learning program, co-certified with IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role and get you ready for that. For more information, check the link in the description box. Also, tell us in the comment what other AI topics you would like us to cover. So let's get started. So in this particular video, we are going to discuss about the very first component of LangChain, which is your model component. First of all, I will explain you a little bit background about this component, and then we will deep dive into the coding part. So today we are going to code, and you guys will also be enjoying the coding part. By the end of this video, I'll be also demonstrating one very small project which will help you to get that confidence of working with LangChain and working with AI. So let's get started. If I quickly recap the last two videos, in the first video, we discussed about AI and how chatbots evolved into chat GPT. And we also learned about various elements of AI, which is agentic AI, AI agent, and then AI workflows. In the second video, we understood about LangChain. And we had a detailed discussion about what is LangChain, what are the key components of LangChain, also what is the library structure of LangChain. So we talked about various libraries, which is LangChain Core, LangChain Community, LangChain Classic, LangChain Experimental, LangChain OpenAI, LangChain Anthropic. So we talked about all these things. Now today, in this third video, we will start with the very first component of LangChain, which is the LangChain models. Now, in the last video, I have given you a very brief idea about why this particular component is the crucial component of the entire LangChain framework. So we will extend that and we will talk about all the components or all the sub-components under the LangChain model. So we have learned that um, your LLM or all the LLMs, whether it is your OpenAI or whether it is your Gemini or is it your Claude, all these LLMs are very big models. So when I say big model, their size, basically their memory, uh, their overall memory requirement is very huge. Additionally, if you want to inference, basically if you want to use them to generate some text for you, then it would take a good amount of processing power, which our laptops or our local machines are not capable of. And that is the reason all these companies or LLM providers, what they did, they allowed the developers to connect with the LLM using something which is known as API. And now if this is your machine or Python or application, you will be able to connect your machine, your application with the LLM using the API. I also told you that you need to pay for it because if you are using OpenAI, ChatGPT, Gemini, or Cloud using their web interface, so if you go to chatgpt.com or gemini.google.com or Claude, which is Anthropic, claude.com, you will get this interactive web web application where you can talk to these models and get your task done. Mostly these are free for early use, Basically, if you are not a that much great user, if you have limited task per day, you can use these platforms for free and you do not need to pay for it. But when you want to use these models in your application using API, you have to pay for it. And that is the very first requirement which you need to fulfill. So I'll tell you how to purchase this and I will tell you everything. But that is the very first requirement, that you need to have some credits in your account to use them. But that's not the only thing available in the market. There are nice people also. So there are some free open source LLMs also. And these free open source LLMs are available for free of use. So you can either download them or you can either use them in some kind of inference website. I will explain you all these terms. But in nutshell, the LLM community has provided two kinds of LLM. One is basically driven by these major tech giants, OpenAI, Google, Gemini, and Claude. So these are tech giants that are providing you with their LLM as a service, and you need to pay for that service if you want to use their API. But there are some nice people also. They have provided their LLM for you free of cost, and that are known as the open source LLM. Now, all these open source LLM are available on this website known as Hugging Face. So Hugging Face is basically the biggest repository of all these LLM models, be it the language model, be it a multi-model, be it a text model or image model or a video model or a audio model. You will be able to find out all these models in this single website, which is Hugging Face. In nutshell, you can use LLM after paying using their API from the major tech giants like OpenAI, Gemini, and Claude. Or there are multiple companies, but I'm rating these few names. You can also use LLMs from this open source community, and you can find out all these models on this website, which is Hugging Face. And one of the very popular LLM, which is open source, is Llama. And this is from Meta, which is your Facebook. So I will demonstrate you how we will be using it. And this is basically the LLM. But these are known as your chat model in LangChain, chat models. So in LangChain, your models are of two types. So in LangChain, the models are divided into two components, or there are two types of models in LangChain. One is your chat model, and the other one is your embedding model. Now, chat models are those models which provides you with the functionality of natural language understanding and text generation. So basically, here you get the techniques or basically the power of natural language understanding and context based text generation. So this is what you get in the chat model. And chat models are free and paid. So we have paid and we have free also. So paid are what we talked about over here, and free are basically your Hugging Face. Llama is one such example. Now, embedding models are those models which are not generating any text, but they take input as a text and returns the vector as the output. Remember in the first video, we talked about these embedding models and why we need them. Basically, what happens if you want a machine, because in nutshell, all these LLMs are mathematical machines, and these machines cannot understand the words or the characters. All they can understand is the numerical representation of these words and these characters. So these machines are designed, which are basically based on the maths. These machines are limited to the understanding of numbers. Now, what these embedding model do, they take, so this is my embedding model, EM, they take text as the input and returns a vector as the output, which is basically a vector that is describing or capturing the contextual meaning of the text. So this vector is not a random vector. There is a technique that is going inside this embedding model. So these embedding models are basically based on the concept of neural networks, and using the concept of neural network, we are trying to convert or represent this text into a representative vector or numerical vector. And this vector is capturing the contextual meaning behind this text. So why this is useful? This is useful because now you can convert your documents, your data, your text into these vector, the numerical representation, and then you can perform variety of operations like finding out a similar document using semantic search. You can also provide this to your LLM to generate more documents for you. So we will be using these embedding models when we'll be applying the concept of RAG, when I'll be teaching you about end-to-end RAG deployment. But as of now, in nutshell, these embedding models are doing only one task. They take a text and they return a vector, which is the representation of your textual data in a form of a numbers. These numbers are capable of capturing the contextual meaning of your text. So before we jump on understanding the implementation of all these models, let me also give you a brief understanding about what this contextual meaning is. Now, one way to convert a word to a number is simply performing label encoding. So let's say if I have Kanpur, I can represent 1 for Delhi, I can represent 2 for Bangalore, I can represent 3. So these are known as label encoded words where I have assigned a random number to a word. But this is wrong because here we are not keeping the context in picture. So, what is the meaning of context? If you think about it, if I have a word king, then if I have a word queen, then I have a word men, and I have a word woman. Now, the relationship between all these words are something which also exist in real life. There is a relationship. And what is that relationship? When I take king, subtract men to it, and add woman, I should get queen, right? That is what the logic is. And this is exactly what your embedding models are trying to do. They are not randomly representing a word or a sentence to a number. They are trying to also make sure that their contextual meaning is also captured in those numbers. And without the contextual meaning, your LLMs will not be able to perform any task. So the reason today we are able to use LLMs so well in all the natural language understanding task is because of this core concept, which is the word embeddings. When we convert a word into a representative numerical vector, we are not doing it randomly. We are doing it keeping in mind that the context is also preserved. And that is what the contextual meaning is. So I will not take much time because this is a concept of natural language understanding. But I hope you guys would have understood that in broad, we have two kinds of models. One is the chat model, then we have embedding model. In chat, we have free and paid. Embedding models are also free and paid. The free models for embedding are available in same place, Hugging Face, and we are going to use them and we are going to also code. So let's start the coding part now. So before we can start coding, I need some important packages. Together with that, we also need our API key. So I'll start with getting the API key. You need to go to OpenAI platform. This is platform.openai.com. You don't need to go to the this playground, but OpenAI platform.openai.com, and you need to get your account. So I have my account over here. Go to this setting. In the setting, you will find out these API keys. So as of now, I have these many API keys running, and you can create your own API key and you can copy it. I have copied it, I have created. Remember one thing, you need to add some amount to your account. You cannot use it for free of cost when you're using OpenAI. You have to make sure that at least $5 are in your account to use the um, OpenAI API keys. So that is going to take around 500 rupees, and I believe for learning purpose you can spend 500 rupees. You can use your credit card to pay for it, and you will be able to use this API key without any problem. So this is where you can get the API key. Now what you need to do, you need to go and create a file. So first of all, I need to connect. And for all the demonstrations, I will be using Google Colab, so that you don't have to set up anything in your local system. Once connected, you can go and simply create a new file over here. So click on it and click on new file. And here you can name the file as .env. Now remember, once you create .env, this I sign, if by default it is hidden, so you will not be seeing those .env file, the environment file. So you have to make sure that this is open. So this I should be not hidden. From here you can see we have .env file, and this is the file where we are going to preserve all our API keys, and API keys are confidential, they are secret. That is the reason we are creating a separate file, and we are preserving all the API keys over here. So from here, over here, you can simply write OpenAI API key is equal to your key. So here, after writing this, you can mention copy paste your key. So from here, you need to copy the key and you can paste over here. So that's how you will be able to get your API key set up. But I will not be doing this. I will be just deleting it, and I will just upload the .env file. So here we have the .env file. I will upload it over here. I will rename it to .env because right now this is simply env. So rename to .env. And this is the same file which I have shown you to create. Once created, here you can see that I have all the API keys. OpenAI HF token for Hugging Face, I'll tell you that also. Assembly AI, I'll tell you about that also. Google API key for Gemini. So I have all the keys. I'll just close it. I'll copy the path. And now here I'll write. So to load these API keys into your current runtime, you need to use .env, .env, and then you just simply have to say .env dot, you can load underscore dot env. And here you mention the path. So I'll copy this path and place my path over here in inverted commas and run it. I should get a true. So when it says true, that means my API keys are loaded in my current session. Now I need some packages. So pip install -q, which basically means I want to quietly install LangChain underscore OpenAI. As I told you in the previous video also, that LangChain offers a variety of chat packages. You have a package for OpenAI also, you have a package for Google Gemini also, you have a package for Claude also. So all these packages are for these respective companies. So all the associated work or the usage that you want to do with their platform or their API, you need to use their respective package. But this respective package is not controlled or maintained by OpenAI. This is basically maintained by LangChain, and this library is inherent to the LangChain underscore core, the base library of LangChain. So there is inheritance property that is maintained between this library and the LangChain underscore core library. Together with that, I don't need anything else. So yeah, let's install this. And once this is done, from LangChain underscore OpenAI, I will import chat OpenAI because I want to use the chat functionality of OpenAI. I want to use the LLM functionality. I will create a object model is equal to chat OpenAI. And here I need to mention the model I want to use. Now, if you go and Google chat OpenAI models, you will get the model OpenAI API, and here you will get all the models that are available. So these are all the models that are available. GPT 4.1 mini, GPT 4o mini search preview, GPT 4.1 nano. If you want to just carefully copy paste their name, just go to chat OpenAI, and here you will get the list. I think the model list is removed from here. So I think we can use from here itself. Let me use this one. I'll just copy it from here, GPT 4o mini, and place it over here. So you can use the name like this, and let's run it. Now you can see that my model is set up. Now, if you want to ask this model any question, just simply say model.invoke. Now we'll be using this method a lot of time. I'll just pass my question. What's the capital of India? And let me run it. So here you can see we have a very detailed AI message from this particular model. What we are going to do, I'm just interested in the content part. So let me preserve this result in the variable result. And I'll simply say that I want result dot content. And let me just put all this in one cell over here, and let's run it. So here you can see we have the response. The capital of India is New Delhi. This is how you can use the uh, OpenAI API, and you can query the LLM, and we are using this LLM. Additionally, what you can do, you can also add some more attributes while calling this function chat OpenAI. So there is another attribute which is temperature. Now, temperature is a very important attribute which controls whether you want a deterministic output or whether you want a more creative output. So if the number is 0, then every time you run, you get the same output. But if the number is closer to the number 2, so this temperature ranges from 0 to 2. 0 to 1 is the traditional range that people use, but nowadays people are using 1.5 and 2 also. When you reach towards 2, when you increase this number, you get more creative answer. Basically, you will get more out of box answer, more sarcasm answer, more beautiful, I would not say beautiful, but more creative answers. So when you want to control the output of a LLM, you can keep this temperature to 0. This will make sure that every time this LLM generates the output, it is exactly the same. For a given question, it will not change the answer. So if I keep the temperature as 0, I'll get the answer as the capital of India is New Delhi. But if I keep it 2, I will again get the answer which is the exact same answer, because this is something where LLM cannot show a creativity part. So let me try to change the question. Let me add, give me a name. I am from India, Kanpur. I am keeping creativity as 2, which is temperature as 2. And also I will keep 0 also. So let's see the difference in the answer. So this is temperature as 2 and this is with 0. Let's see the difference. So you can see that when I kept it as 2, it has given me the name Arav, but it has also generated some very good amount of data, which is clearly not matching the context. Here you can see that the output is more deterministic and more controlled, right? You can see one more problem, that it has generated good amount of tokens, which is words, which I don't want, right? I want the answer to be very small. So one thing which we can do is we can control the number of tokens that I want the model to generate. You can either use max completion token, which is from the lower version, or you can simply use max token. I want only 20 tokens to be generated in both the cases, so that I can control the response. And let's see now the output from, okay, tokens. There is a S. So let me generate this and let me generate this here. Over here also max tokens too. Now here your answer is sure. How about the name Arav? It's popular name and meaningful name in India. Sure. How about Arav? It's popular name in India and means. Now here you can see that since I have restricted to 20, it is not able to complete the sentence. So you can play around with this number to control the amount of output you need. But I hope you are able to understand how to use this simple interface or simple code to talk to the OpenAI GPT model, and you can choose the model which you want to choose from this particular web page that they have maintained very well. Now let's understand how we can use Google, Google Gemini. So for Google Gemini, again, the very first thing you need is Google API key. And to get your Google API key, just Google Gemini API key, enter. You need to go to this link, Google API Studio API key. And then I have to switch my account because I don't want to use this account. So I want to use this account. So this account has a pro version. So if you are in a pro version, good part is you don't have to put a recharge. As of now, I'm a free trial. In free trial, you get limited credits. You just need to click on this create API key. You need to select a project. If you don't have a project, just create a project over here. Put your name and copy the key. Once you have copied the key, go back over here in the .env file. create this name, which is Google API key, and you can put your API key against it. One thing I forgot to tell you that these names are exactly need to be written in this particular uh, order, and also you need to match the cases. You cannot use a small and mixed cases. You have to exactly type it like this: OpenAI API key, and you have to use these underscores. So if you mismatch this will be a problem. So let me import the package for generative AI, Google generative AI. So Google Gemini, and for Google Gemini, we have the package which is pip install minus q. It is LangChain underscore Google underscore Gen AI. So this is the package name. And once this is done, you can ignore these warnings. There is a very great amount of problem right now with the dependencies, and LangChain is trying to solve this problem. As I told you in the second video, the LangChain has evolved so much that these dependencies problem will exist for some time, but you can ignore it as of now. From LangChain underscore Google underscore Gen AI import chat Google Gen AI. The process is same. Create a model. Model is equal to chat Google Gen AI. And here also you need to select your model. Now again, let's go back to Google Gemini models. So these are the Gemini models available. So here we have 2.5 Pro, 2.5 Flash, Flashlight, 2.0. So these are the models. I will be using this 2.0 flashlight. So let me copy this and paste it over here. I can remove this. I don't need this. I can just put Gemini 2.0 flashlight. And let's invoke this model.invoke with my question. What's the capital of India? And this will return me a result, which I can take the content. Now, best thing you can understand, there is a problem. Chat Google. Okay, there is a change. This is function has been changed to generative AI. Okay, here also I need to change. You can see this is able to work. So this is the new function, chat Google generative AI. One thing which you can compare is this and this. You can see that the way we have written a code over here is exactly the same over here, and you get the same parameter over here also: model, max token, temperature. All these attributes are available in this function also. So the reproducibility, the way to work with multiple models is very convenient using LangChain. You can work with OpenAI also, you can work with Google Gemini also, and you can choose your model of your choice. Okay, so this was basically working with OpenAI and Gemini. Let's now work with the Hugging Face free chat models. So again, you need to have your Hugging Face account. Go to huggingface.co and get your API. So once you have your account, click on this, your label. Over here, you can see access tokens, and you need to confirm your password. So let me confirm my password. And finally, you will be able to see, you can click on this create token. And since I want to read right now, just give your name to your token, create your token and copy it. Once you are done with that, close it, come back to your .env file, double click and preserve your tokens like this. HF underscore token is equal to this. And once you are done, you will be able to work with Hugging Face chat models. Now, remember one thing. Hugging Face provides you the inference API also, and Hugging Face provides you the way to download these models locally also. The inference API as of now is not working properly for Hugging Face. When I was trying, so I was trying the whole day. I was not able to find out the solution to that problem. So as of now, what I'll do is I'll copy paste the code for inference API. You can try it out, but for the download part where we download and we use it locally, I'll show you that and I will work on that. And that is actually easy, but it requires a good amount of processing power if you are using your local computer. As of now, I'm using Google Colab. So Google Colab will download the model for me and it will preserve the model in its server. Over here you can see we have got a space, RAM and disk space, so we'll be using this. So let's use Hugging Face. First of all, I need to install the package. Pip install -q, and again the package name is very simple to remember, LangChain underscore Hugging Face. Hugging Face. So once this is done, you need to get from LangChain underscore Hugging Face import chat Hugging Face, and with that I also need Hugging Face pipeline, this one. So this is used to download the package or the complete model, and this is to chat with that particular model. So let me create the object LLM, or you can create the object model. Model is equal to Hugging Face, and this is not, let's call it as LLM because we are downloading the LLM. Hugging Face pipeline, and here you have to also use the sub module which is from underscore model underscore ID, and then you need to provide the model ID. So if I go to Hugging Face, I can choose variety of models. If I go to Hugging Face and click on this models, I have so many models available, and these are very huge models, but we cannot use them. Which model we are going to use? We are going to use Tiny Llama. So if you type Tiny Llama, you will get this 1.1 billion parameters. I'll copy this and I will use this model over here. And then there is a parameter task which you have to mention. So task is your text generation. You can copy this also. Just simply mention task is text hyphen, and please remember you have to mention it like this only, text generation. Once my LLM is downloaded, I will create the object model, which is chat Hugging Face. So this is my now the model. And now we can invoke this model exactly in the same way as we have done for other paid models. Let's run it. Okay, there is a problem. There is a comma missing over here. Let's run it again. Now this will download the entire model in this particular server, which is the Colab server, and it will take some time. Now here you can see that it has downloaded the entire model, and now we are able to use this model to get the answer. So if you want to reuse this model, just use this model.invoke and you will be able to find the mistake in the sentence, in the word. Uh, let's write it. New Delhi. Let's see if it is able to. identify the spelling mistake. Remember now this model is basically the model which I have downloaded from this website which is Hugging Face. So we are using Tiny Llama from Meta, and this will take time. This is not going to instantly give you the answer. This will take time. So the mistake in the word New Delhi is the apostrophe I. It's any Delhi, neutral gender. So maybe it is not able to perfectly answer me this, but this is what the way to use the free models. Now let's start the discussion on the embedding models. So embedding models. So for embedding models, the process is very simple actually. It is actually very simple. Just say from LangChain underscore OpenAI, I want to use OpenAI embeddings. And here you have to mention the embedding model for OpenAI also. So just Google OpenAI embedding models and you should be able to see a lot of models. I am not interested in the pricing as of now, models only. So these are the OpenAI embedding models. Yeah, these are the models. Text embedding 3 small, 3 large, ADA 002. And the pricing is also very less actually. So assuming 800 tokens per page, this provides you per dollar 62,500 pages. And it also writes that by default the length of embedding vector is 1536. I'll tell you about this. For a small, for large one it is 3072. So you can see that the pricing is very small. I will use this small one as of now for the demonstration purpose. I will copy it over here. So again, you have to same mention model is equal to this model. And then you say embeddings dot, we have to convert the sentence as of now. So we will use embed underscore query. And here you mention what you want to embed. So let's say the same word. What's the capital of India? And now you have to also mention one more parameter, which is the size of the output, which is the dimension. So dimension is something which you mention over here. Dimensions. Now, what is the meaning of dimension? So let me explain you that part. So when you convert, this is your embedding model. When you provide a word or a document or a text, so document or a text or a word, it returns you a vector. Now, what is the size of the vector you need in the output? Do you want a vector of, let's say, 2 dimension, 3 dimension, 4 dimension, 1000 dimension, 100 dimensions? The advantage is more the dimensions, the better is the context capture. Better context capture. So, which basically mean if you keep the dimensionality to be high, you are able to capture more meaning of the words in the sentence, and then the searching operation or all the operations that you will do on this vector will be super good and efficient. So as of now, for just demonstration purpose, we will keep it, let's keep it 50, and let's preserve it in a vector v, and let's see what is v. So v. So this is the vector v with 50 dimensionality, right? So this entire text is represented as this in numerical form, which is the embedding vector. Now what we will do is I will try to do the same thing with set of documents. So let's say if I have these two documents, how we can convert them all together into embedding vectors. So all you do is copy the same code. Here I will reduce the size to 10 And instead of this embed query, we will use embed documents. That's it. Run it, you are done. So now you will get a list, which is list of list, where you have one list for each document in your particular in your document list that you have provided. So that's how you do it for documents. Now these functions or methods will not change if you change your model, as we have seen previously also. That is the advantage you get working with LangChain. If you want to embed your query, just use embed query. A query means a sentence. And if you have a list of documents, use embed documents. Now we have a free version also. So basically, if you want to work with Hugging Face embeddings, so Hugging Face free embeddings, how we can use it? Again, I will download the particular model into my system. So from LangChain underscore Hugging Face, you need to get Hugging Face embeddings. Then you create the object. And here, if I go back over here, you search for sentence transformer. So this is the model which we will use. It is a very small model. I think it will be under 100 MB. This is a very small model which we'll be using. So model is this. And again, the process is same. Let's convert this to abd underscore h, emb underscore h, and you say dot embed query. What's the capital of India? This will return you the vector v, and this is my embedding. Now this will again download the entire model, so it will take some time. So here you have the result. You have the result for this. Now this output is of, I think, 300 dimensionalities. Let me just check quickly. The output is of 384. So it will by default going to return you the dimensionality of 384 for each word or for each input that you provide. So it has converted this into entire list of numbers, which is basically your vector. Now, before we conclude this video, let's create a small application where we are going to use the embeddings to search for similar sentences. We are going to use the concept of cosine similarity. So what we are going to do is, if this is my two-dimensional space and I have a word, um, let's say about Delhi. Delhi is the capital of India. Now, let's say my query is what's the capital of India? So what we are going to do in this application, we are going to first of all create a list of documents where I will have multiple documents about various cities. I will give this to my embedding model and I will get the corresponding vectors. Now I will have my query, which is my question. I will again give it to the same embedding model and I will get the embedding or a vector for this also. Now I will call this as a VQ query vector and VD document vector. I will use the concept of cosine similarity and we will try to find out the most similar document to the query. Now, what is cosine similarity? Cosine similarity is basically the technique of finding out the angles between the two vector. So if this is one vector and this is another vector, then cosine similarity is basically finding out this angle. So if two vectors are similar to each other, their cosine similarity would be less, their angle would be less. And if two vectors are very apart from each other, their angle would be high, so their cosine similarity will be high. So that is what we are trying to do. Let's try to do it. So let me create a list of documents. So I have already prepared it. These are the list of documents. And what we are going to do, we are going to use OpenAI embedding. So from LangChain underscore OpenAI, import OpenAI embeddings. I'm going to create my embedding model. So EM is equal to OpenAI. And let me just simply copy paste. Yes. So we will copy this. And we are going to embed the docs, and we will get the output V. But I don't want that a B. So we will create a queue also. Queue is to embed query. Now, and let's use this. Where is Charminar? And now I will use NumPy. So import NumPy as NP to get the cosine similarity. So NP dot from scikit-learn dot metrics dot pairwise, we get cosine similarity. Cosine similarity. So I'll now simply use cosine similarity. This Q has to be also provided as a vector. So I'm providing it in a list. And this V is already in a vector because it will be a list of list. So I'm providing this. I'll get a result. Let's preserve this in R. Now this is my R. I need to find out the smallest value. So I will use arg from this R, np.argmin, and that is 6. So 1, 2, 3, 4, 5, 5, 6, Hyderabad, right? So this is the simplest way to find out the similarity. And what I have done is we have first of all used the embedding model to get the document vectors. We have used the same embedding model to get the vector of my question. We performed the simplest cosine similarity technique to find out the similarity score, the basically the angle, and we want the minimum angle. That is my answer. So I hope you guys would have learned a lot about the models, the model category or the model functionality of the entire LangChain framework. So this is all about for this particular video. I hope you guys enjoyed. I hope you guys learned a lot of things. I will request all of you to make sure you practice along with me with every new video that is going to come up. We are going to add more and more complexity so that you are able to build a end-to-end AI application by the end of this series. But before I wrap up this video, I request all of you to mention your comments about how this series is going on. If you want us to add something, if you want us to incorporate some of your suggestions, please post your suggestions. Please share this video with your friends who are also looking to upskill and who are also looking to get into the field of AI and learn generative AI. I'll be meeting you in the next video. Till then, take care and keep learning.